Hello and welcome to part B of the video Back to School AP Calculus. In this section we're going to be reviewing logarithmic, exponential, and trigonometric functions and how to simplify and solve with those. So the first example that we have is log base 3 of x plus 2 minus log base 3 of 5 plus log base 3 of 4x. And we're going to be simplifying this. So because they all have base 3, we can pretty simply kind of combine those all. So the first thing that I'm going to do is I'm going to make this log base 3 of x plus 2 divided by 5, because we know that whenever we have subtraction, that turns into division. And I'll say plus log base 3 of 4x. And whenever we have addition, that turns into multiplication. So we have log base 3 of 4x times x plus 2 over 5. So pretty simple. Just remember that whenever you are subtracting logs, then you can combine them using division, and whenever you're adding, you can combine them using multiplication. Okay, moving on to our next example. This is more of an exponential equation, but we're still going to have to use logs with this to solve it. So the equation is 3 to the 2x equals 4 to the 5x minus 1. Now, if we apply logs to all these, we get log 3 to the 2x equals log 4 to the 5x minus 1. And since we do have these things kind of exponent, we can bring this out to the front. So 2x log of 3 is equal to 5x minus 1 log of 4. And we know that this is equal to 2x log of 3 equals 5x log of 4 minus log of 4. And then we can bring all the x's over to one side and take out the x. So x times 2 log 3 minus 5 log of 4 is equal to negative log of 4. And then we know that x is equal to negative log of 4 over 2 log of 3 minus 5 log of 4. So there you go. That's the exponential. Now let's kind of move on to some of these trigonometric functions. So the first one that we have is cosecant 55 degrees over secant of 325 degrees. So this is going to be equal to 1 over sine of 55 degrees over 1 over cosine of 325 degrees. And so we're going to change the cosine on the bottom. Well, first let's make it cosine 325 degrees over sine 55 degrees. Remember, we're just multiplying by the reciprocal. And then this 325 degrees, using the unit circle, we know that there's a reference angle there of 35 degrees, which means that we can say this is also equal to cosine of negative 35 degrees over sine of 55 degrees. Now remember that cosine is an even function, which means that we can just make this cosine of 35 degrees over sine of 55 degrees. Now, what to remember here is that cosine and sine work on a 90-degree kind of period, right? So a pi over 2 period. So cosine of 35 degrees is also equal to sine of 90 minus 35 degrees. And we'll do over sine 55. Over sine 55. Now 90 minus 35 is 55. So sine 55 over sine 55 is going to equal 1. So pretty self-explanatory, but it's good to kind of review those functions. Okay, the next thing that we're going to be looking at is we have here cosecant 75 degrees plus sine negative 15 degrees times tangent 15 degrees. Okay, so first I'm going to make this 1 over sine 75 degrees plus negative sine 15 degrees. Remember, sine is an odd property, odd function, times sine 15 degrees over cosine 15 degrees. Remember, we can do that with tangent. And so now I'm going to say that this is equal to 1 over sine 75 plus negative sine squared of 15 degrees over cosine 15 degrees. Now remember what we just discussed in the last problem. Whenever we have cosine of 15, we can also make that sine of 90 minus 15, which is equal to sine of 75. So we have 1 over sine of 75, and we'll say still plus negative sine squared of 15 degrees over cosine of 75 degrees. So remember what we're doing with that 90 degree period there. And now this is equal, because we have, this should be sine of 75 degrees. Now because we have equal denominators, we can just go ahead and add these. So 1 plus a negative is just going to be 1 minus sine squared of 15 degrees over sine of 75 degrees is going to equal cosine squared of 15 degrees, remember those Pythagorean identities, over sine of 75 degrees. And that's going to equal cosine squared of 15 degrees over, and now we're going to change this to cosine of 90 minus 75 degrees, which is going to equal cosine squared of 15 degrees over cosine of 15 degrees, which is just going to equal cosine of 15 degrees, because the cosines cancel out on the top and bottom. So that one was a little bit of a harder example, but kind of remembering those Pythagorean identities, the even-odd products, that kind of thing. Okay, now, looking at this last example here, this is a lot of unit circle knowledge, which is a really good thing to review. So, sine 45 minus cosine pi over sine of 240 degrees. So you can see we're kind of mixing radians and degrees, plus tan 330 degrees. So first, remember that sine of 45 is root 2 over 2. If you need to review that unit circle, I definitely would do that. So root 2 over 2 minus cosine of pi is going to be negative 1. Remember the unit circle, over sine of 240. So 240 has a reference angle of 60 degrees, right? So we know that this is going to have a reference angle of 60, and since sine is negative in the third quadrant, we know that this is going to equal negative sine of 60 degrees. And this is plus tangent of, and 330 has a reference angle of 30 degrees. So we can just say plus tangent of negative 30 degrees. Okay, now when we're looking at simplifying this, we know that this is root 2 over 2 minus, and now these negatives can cancel out, 1 over, and sine of 60 degrees is root 3 over 2, plus, and tangent of negative 30 degrees is going to equal sine negative 30 over cosine negative 30. And you can also just remember the unit circle for tan, but I find it easier just to write it all out. And this is going to simplify to negative 1/2 over root 3 over 2. So the root 2's are going to cancel out. So then you have this is going to equal negative 1 over root 3. So kind of simplifying this whole thing, we have root 2 over 2 minus, and when we have 1 over root 3 over 2, we can just say this is 2 over root 3 minus 1 over root 3, And I'm going to say that this is going to be equal to root 2 over 2 minus 3 over root 3. And if you want, you can bring that radical up to the denominator. Some people like to do that. That's really a choice. So that's it for your back to school AP Calc review. Hopefully you feel a little bit more ready now, and I would encourage you to look over some other basic functions such as x cubed, cube root of x, square root of x, those kind of things. I think those are a little bit basic to cover at this point in this video, but make sure that you understand a lot of the stuff that's going on in here, especially the domain and range of those functions. Thanks for watching.